Batteries are parts of our everyday life. A day would not last without using our handphones. Every time we go out, we either drive our car or take a public vehicle. We use a remote control to switch channels while watching television. We unconsciously bump with batteries in everyday events. Hi, my name is Hatim El-Warid and today we're gonna talk about batteries. First, the battery is a self-contained chemical power pack that can produce a limited amount of energy whenever it's needed, unlike the normal electricity, which flows to your home through wires that start up in a power plant. A battery slowly converts chemical packed inside it into electrical energy, typically released over a period of days, weeks, months, or even years. But before we see how actually this happens, let's take a look on the battery components. Batteries are made up of three components. The anode, it's always marked as the negative side of the battery. Electrons flows out of the anode. And then there is the cathode, it's always marked as the positive side of the battery. Electrons flows into the cathode. And finally, there is the electrolyte. It's usually a liquid or gel that reacts with the cathode and the anode. When we connect the circuit to the battery, a chemical reaction occurs between the anode and the electrolyte. This chemical reaction produces electrons in a process known as oxidation. At the same time, another chemical reaction occurs between the cathode and the electrolyte. This chemical reaction requires extra electrons in a process known as reduction. To make this chemical reaction happen, electrons from the oxidation side need to move to the reduction side. Welcome to my lab. As you know, there is two types of batteries. Secondary batteries that can be recharged like this lithium-ion battery, and primary cells that cannot be recharged like this. To demonstrate how this works, we can create our own battery only using lemon, zinc, iron, an LED light, a multimeter, and finally some wires. When the battery is producing a current, the zinc, which is our anode, reacts with the acid in the lemon. This produces electrons that can be moved through our circuits to the iron, which is our cathode. As you see, the electrical potential between the cathode and the anode is about 1.3 volts, which is high enough to light an LED. It might be a bit dim, so you probably want to look at it in a dark room. Thank you for watching, and I really hope you enjoyed this video.